Hello.
Hi.
Can you guys see my screen?
Yeah.
We're gonna give 5 minutes for people to trickle in, and then we can start. While you're waiting, can you put your school email in the chat as well as something you're grateful for?
Sorry, can you repeat that? It like cut out for me.
Oh, I said we're gonna wait a few minutes for people to trickle in, and while you guys wait, can you guys put your email, your school email in the chat so I could take attendance as well as something you're grateful for? I'm grateful for daylight savings because now we get longer sunsets, later sunsets. Okay, let's begin. So this is like a Jeopardy style review session. So it's going to ask a question and it's gonna say a statement and you're gonna answer in a question. And you can either shout it out or put it in the chat. Okay, let's begin. How are proteins created? DNA has the formula for it, and the messenger RNA, passes it on to ribosomes, which are created in the rough ER. And then the tRNA creates the polypeptide chains, and they're exported through the Golgi apparatus. Why does our bodies need protein? What do proteins do?
For muscle building.
Yeah, they're for muscle building as well as all these things. As Dr. Rose calls it, they just do the work of cells. This synthesis of body proteins for cell structure, enzymes, hormones, and muscle protein. What causes protein to denature and why is denaturing important?
Is temperature a cause?
Yeah, temperature is a cause as well as acid. Denaturing is breaking down the proteins so they're not functioning anymore. And it's super important because you don't want to consume the protein and have it still have its function. Because that'd be kind of scary. You don't know what's going to do to your body. But like, yeah, temperature, enzymes, acid, alkaline solutions, and agitation causes proteins to denature. It reduces biological activity, and you don't want proteins to work when you consume them. You want them to be reduced to their building blocks, which is what our body does to the rest after it gets denatured. What are food protein allergies?
Is it like nuts, soy, shellfish, seafood,
Yeah,
peanuts, and there's some other ones I forgot though.
Yeah, those are very specific examples, and everybody's body's different, and some people might be allergic to a food protein that other people might not. And there's like that, I think it's like the major nine that,
Yeah,
and then there was like a new one that was accepting me. I think that's what you're talking about.
yeah,
But
I thought that's what it was asking. My bad.
yeah, no, but those are good examples of it, and it's good to know,
Yeah.
especially if you work in the food system. But what they are specifically, it just makes our bodies, our immune systems have like a reaction and overreact, even though it really doesn't do anything. Introducing these early in life can prevent allergies, and that's why a lot of parents feed it to their kids at 6 months. How does protein move substances across the plasma membrane?
Doesn't it change shape?
Mhm. They also pump chemical ions in and out of cells in sodium potassium pumps. Proteins are also known as like receptors or transporters. So I feel like saying it as proteins is a bit confusing, but they're all like um, interchangeable. And they move substances up their concentration gradients and help hydrophilic substances cross plasma membrane. They're carrier proteins, and sometimes they require ATP. Okay, for lipids. What are cis and trans fats?
Like they fatty acids, like cis fatty acids have double bonds on the same side, and trans fatty acids have like bonds on opposite sides.
Yeah, they're byproducts of hydrogenation, and they're double bonds that have been straightened out, and hydrogens facing each other, or hydrogens on the opposite side. Partial hydrogenization of unsaturated fats result in some formation of trans fatty acids. And trans fats have actually been banned in the US because our bodies cannot process it, which is a fun fact. What are signs of fatty acid deficiency?
Is one of them like long shelf life and then it like separates and stuff?
Involve epithelial tissues because cells are rapidly turned over, skin becomes flaky and itchy, wound healing may be slowed, may experience diarrhea, hair may fall out or lose pigment, more vulnerable to infections, growth may be restricted among children. I think this is one of the rarer nutritional deficiency because lipids are very like prominent or like abundant in children's diets, at least in America. So this is like not something a lot of families worry about in America, at least. But if they are deficient, this is some signs of it. But a lot of nutritional deficiency can be seen on the skin first, like primarily. What are chylomicrons and why are they important?
Don't they allow larger fats to get transported throughout the body?
Yeah, they are a bunch of different fats packed into lipoproteins called chylomicrons. And the question I also asked is why does lipids spend so much energy breaking down lipids just to go, like, why do they do this? And it's because as soon as they go to the small intestine, they immediately form into these. Like, why does that happen? And it's because fat is not water soluble. You have so much water in your body, especially in blood vessels, where they move around. And so if there isn't a system in place, then the fat is just going to float around everywhere, like, in a salad dressing, how the oil just like rises to the top. So these chylomicrons help them move in an efficient way to transport around. And it's safer to transport fats so they don't collect and coalesce and attach to arteries. Yeah. And they look really cool. They're kind of like super gnarly and like, yeah. What are the differences between low density lipoprotein and high density lipoproteins? LDL carries cholesterol made by the liver and from other sources to cells. Oxidized LDL particles are taken up by scavenger white blood cells to form plaques in blood vessels, which increases the risk of cardiovascular disease. On the other hand, high-density lipoproteins remove cholesterol from cells and tells the liver to stop producing cholesterol and excretes cholesterol from the body, which reduces risk of cardiovascular disease. Our body produces cholesterol already, so when we consume cholesterol, um, HDL tells our body to stop producing more. And that's important because having too much could lead to cardiovascular disease. What are differences between omega-3 and omega-6?
Is it like the formation of like the carbon with the hydrogen? Like it's like different, it's bonded to different carbons or something like that?
Yeah, and because of this one chemical molecular change, they have completely different characteristics. Like omega-3, it decreases blood clotting, increases vasodilation, and also decreases symptoms of rheumatoid arthritis and behavior disorders. And it's in fatty fish, canola, walnuts, flax seeds, mussels, crab, and a bunch of fish. And while on the other hand, omega-6, it increases inflammation and clotting. And it's important to have both of these in like moderation because if you decrease your blood clotting significantly and you get an injury, your body won't clot it the way it's supposed to. While on the other hand, if you consume a lot of omega-6, you might have way too much blood clotting, which could cause problems too. So having like appropriate amounts of both is important, not just like prioritizing one because like people influence on the internet says so. Okay, now hormones, absorption, and digestion. What is CCK? Cholecytokinin. Very big word.
Doesn't it cause your gallbladder and your pancreas to secrete bile and lipase?
Release pancreatic enzymes like trypsin into the duodenum to break down proteins into smaller peptides and amino acids for absorption. It causes gallbladder to release bile, to break down fats, and causes lipase to be secreted, yeah, which suppresses appetite. And it works with leptin to regulate hunger, stimulates peristalsis, which is the movement of chyme, which is like food as it's like broken down through the GI tract. So this is a very important hormone. Oh, I skipped it. It's okay. How is protein digested and absorbed? I, so when you consume it, even before you consume it, cooking does a lot to protein. It denatures it like we talked about. And then as the protein moves through your stomach, acid, pepsin, and gastrin starts breaking it down. And in the small intestine, CCK and trypsin breaks it down. And then when it goes to the small intestines, microvilli, surface, and absorptive cells lining it brings it into the body. And because amino acid is soluble in water, they don't need to be repackaged like lipids do. And so they are easily absorbed through active transportation. And then they travel through the portal vein through the liver. How are lipids digested and absorbed? Small intestine's digestion, the bile acids that we talked about earlier, it emulsifies the fat to increase surface area to let pancreatic lipase get to lipid easier to digest. And then it goes through small intestines as chylomicrons, and then it enters lacteals and enters the lymphatic system into the bloodstream where it's dropped off in adipose tissue, which is all over our body. What are the functions of insulin and glucagon?
Don't they
The
regulate blood sugar? Sorry, you go.
No, you're good. Go ahead.
Don't they regulate blood sugar?
Yeah. Do you want to say more about that?
I think insulin gets released if it's too high, and then glucagon is if it's too low.
Yes. Ooh, I have a picture. Okay, let me read this part first. So insulin, in my head, I think of them like a yin yang, like pairing of hormones because what like they are always like in balance of each other where they're supposed to be. So insulin is also known as our fed state hormone because like you said, when your blood sugar is high because you just consumed food to increase your blood sugar levels, insulin is released, which breaks, I mean like it creates the glycogen in our blood sugar and turns them into glycogen. It turns the glucose into glycogen to store in our body because we have too much of it. While on the other hand, glucagon, it notices like our blood sugar levels is really low, so it breaks down glycogen into glucose for our body to use. So they're like yin yang of each other. And here's a picture of that. Oh, I can't zoom out. But on the top, when you have elevated blood glucose from just consuming, your pancreas releases insulin, and then glucose is transported into cells or converted into glycogen. And then it goes back into homeostasis. And on the other hand, when it dips too far low, then it triggers the pancreas to release glucagon, which is the hormone that breaks down glycogen into glucose and increases gluconeogenesis, which is the formation of more glucose from like other sources. And then it goes
Sorry,
back
so
to,
this sorry.
oh, sorry, go
So
for it.
this is just like a negative feedback loop, right? To maintain
Hmm.
homeostasis with the insulin.
Yes, and as well as
And the
glucagon.
okay, thank
Yeah.
you.
So if they're out of whack, then it brings them back to homeostasis. So yes, it is like a negative feedback. What are the differences between type 1 and type 2 diabetes?
Is type 2 where you kill the cells that create insulin, and type 1 is the one where your receptors don't answer to it?
Okay. Type 1 is autoimmune attack on the pancreas, while type 2 is just insulin resistance, like your body isn't producing enough to break down the glucose, while the other one, it's like attacking the pancreas. And sometimes type 2 could evolve into type 1. And the characteristics are similar, but type 1 is more intense. And treatment is also similar, but they could lead to other health problems too. Any questions on that? Okay, carbohydrates. What are the difference between glucose and glycogen?
Glucose is where it's like sugar, like your body, whatever you eat, it breaks down into glucose. And since our body has a lot of it, we turn it into glycogen for storage.
Yes, that is correct. One thing I thought was so fascinating is glycogen is very tightly packed. Because if your body just consumes the glucose and let it like float around in your body, it creates a lot of mass. Like it takes up a lot of space. So it packages it into glycogen, which is way more tight and fits better in our cells. And glucose is the primary carbohydrates our body use to make energy. Our brains especially love glucose. So if you are like feeling a low energy for a test, you should like eat some glucose, something with a glucose, so your brain starts powering up again. And glycogen is actually the primary form of carbohydrate stores in animals. In plants, I don't know if you guys remember what it's called. They store glucose differently than us. Does anyone know?
Is it starch?
They store it as starch or cellulose. I think it depends on the plant itself, but they don't store it as glycogen. Only animals do. What is lactose intolerant?
You don't have the enzyme lactase to digest lactose.
Yes, that's so true. I have it. I know for sure. And it's a reduction in lactase enzyme, like you talked about, and it causes lactose to move to your large intestines and cause gas, bloating, cramps, the runs. And it's not the same thing as a dairy allergy, which is basically that protein triggers a reaction from your immune system. But I feel like it may, like sometimes people have such extreme lactose intolerance that they feel like they're allergic to it, but it's different. Why do we need to consume complex carbs instead of just glucose or other monosaccharides? Why can't we just eat candy all day? That's what the kids want to know, you know?
I think because complex carbs have starch and fiber, and that's important for our digestion.
Yeah, it takes longer for our body to break it down sometimes for high amylose, so like eating beans. So you get like steady energy instead of a sugar spike, such as like short grain rice, high amylopectin, more sugar released into the bloodstream. So if someone needs like sugar immediately, you should never give them beans to eat because it's going to take a while for them to like get out of the crash, but you can give them like apple juice. So sometimes having the faster sugar access is necessary and sometimes it's not. So that's why it's like having the variety is kind of nice. What are the differences between sugar alcohols and artificial sweeteners? Sugar alcohols, also known as polyols, ingredients used as sweeteners and bulking agents. They occur naturally in food and comes from plant products such as fruit and berries. And as a sugar substitute, they provide fewer calories than regular sugar. Contains 2.6 calories per gram. They're basically artificial sweeteners. Artificial sweeteners such as saccharin and aspartame, they contain 0 calories. So it's basically a calorie difference. And people prefer this because sugar, do you remember how many calories that is? Kcal per gram is
Is it
four.
4 calories?
Yeah, it's four. So this is like significantly less, which is why sometimes when people are looking for less, they pick these instead. What are the differences between soluble and insoluble fibers?
Soluble, I know dissolves in water and insoluble doesn't.
Yes, and they're both super important. When it dissolves in water, it feeds our gut microbiota in the large intestines. And there's like so much studies right now conducted on our gut, which is really fun. But one of the like top conclusions is that more diverse soluble fibers you consume, it creates a more diverse gut microbiota, which actually improves your immune system. Because you're basically getting like a diverse like soldiers to fight off like as much, things that are unwanted foreign objects. While insoluble fiber is also just as important because cellulose, the energy storage for plants, because it creates roughage. It creates like bulk, and that's important to like clean, like have movement throughout your GI tract to clean it out. So, and to have like not constipation. So, having both is important in your diet. Okay, others. What are benefits of a plant-based diet?
You're not getting as much sodium, like in comparison to like poultry or like plants. Like there's way more sodium in meats and poultry, I think, because you can get like the same amount of like everything you need in a plant-based diet. Like you don't necessarily need poultry, right?
Yeah, and the health problems that are caused by consuming a lot of anime and animal-based diets is significantly higher than a plant-based diet. And you get more of certain like minerals and vitamins and a lot more phytochemicals because phytochemicals only come from plants, like animals don't have them. But there is one vitamin that's very hard to find in plants, so a lot of plant-based diet consumers consume it. Do you remember what that is?
Is it B?
B12. And B12 is important, you're gonna find out later, because it helps protect your myelin sheaths maintain your myelin sheaths in your nerves so your nerves keep function. What are the recommended dietary allowance for proteins, lipids, and carbohydrates?
I think protein is less than 35% of your total calorie income.
130 grams a day of carbohydrates, zero point 0.8 grams of protein per kilogram of body weight a day. So it varies per person. And there's no RDA for lipids because, like we talked about before, like lipids is not a very hard thing for people to consume. It's like abundant, at least in the American diet. And it also like varies per age. So you shouldn't skip. Also, like children, they would probably require different variations of this, but this is the like average for our demographic of college students. How much calories do lipids, carbohydrates, and proteins offer per gram? We talked about a few.
Is it four
For which one?
for carbohydrates and proteins?
Nice. And what's lipids?
I don't remember.
It's 9.
Is 9. And then do you guys remember what alcohol was? We had a alcohol like number 2.
7.
Yeah. I was like, it's wild that alcohol offers you so much calories. Is coconut oil long or short chain fatty acid? And why is this important to know?
Is it longer?
It was a trick question. It was medium. It was a mixture of both. And that's why it's solid at room temperature as well. It like melts pretty easily. It's saturated, it has no double bonds, and it's absorbed more easily than butter because it has more medium chains than butter. And it's better for people who are underweight, better for people who want to gain weight, better for people with digestive problems. I learned that like sometimes when like people are dangerously low on weight because like having less weight sometimes correlates to more health problems. So they give them a lot of coconut oil to consume so they could gain weight faster. And a lot of the lipids that we are learning, they're like ratios of long, medium, or short chains. It's not like they're all long chain, they're all short chain. They're like ratio, you know what I mean? Like the different ratios. That was also something fun to know. How does a heart attack occur?
Does not enough blood like flow to your heart or your brain, something like that.
So first, well, that's the end result. There's a blood clot in either your that goes to your heart or to your brain, and it causes you to not have oxygen go through it anymore. But like reversing steps, first, your vessel, your blood vessel somehow gets damaged, and the causes are like smoking, diabetes, hypertension, high LDL infection, extended or chronic inflammatory response. So basically, there's an injury to your vessel, blood vessel. Then scavenger white blood cells move to the site and engulf oxidized LDLs from circulation, and that creates plaque buildup on the blood vessel walls, which, because if there's buildup, the tunnels get like smaller and smaller, and that causes vasoconstriction, which causes high blood pressure. And if all of the blood are struggling to go through, it clots, and that's when you start not getting oxygen delivered to your heart or your brain, depending on where the blood clot occurs. And that's what causes a heart attack or a brain aneurysm. Any questions? And that's the end of my review. And we have time for more questions if you guys like. I'll do my best to answer them. And if I don't know, I will email Dr. Rose and get back to you. And if you don't have any questions, please make sure your email is in the chat because that's how I'm going to take attendance. Thanks for
Thank
coming,
you.
everyone.
Thank you.